All right, so because this worksheet is a mixture of all the theorems, the first thing I recommend that you do is identify which theorem is appropriate to be used for each particular problem. And there are some things that we know about, like when you think about mid-segment, just in your head right now, you don't have to say anything, but in your head right now for mid-segment, I want you to think about what does that look like? What does that type of problem look like? So picture a mid-segment problem. I know it's been a week since we were looking at that, but you can hopefully remember what a mid-segment is. Now, think of a side splitter problem. Think of what just one of those looks like in general. And same thing with angle bisector and side splitter. Or I already said side splitter. Similar triangles, that is. So now we're actually going to talk about what you're looking for all four of those. So in case you can't bring something to mind right now, that's okay. So if I look at just these first 6 problems, has everyone pulled up this worksheet and is looking at it? All right, so if we look just at these first 6, within these first 6, we have all 3 types of problems that are all 4 types of problems that we might come across. So I'll start with what I think is the easiest to identify, and which ones of these, 1 through 6, would be angle bisector problems? So I'm limiting your focus just to these 6. You have a thought? So the angle bisector theorem, the name right there tells you you're looking for an angle bisector. 2 and 4. Yeah. So if you look at all the other problems, 1, 3, 5, and 6, there's no angle bisector in those diagrams. These definitely have a unique appearance to them because we've got one angle being bisected. So this is going to be a classic case for using the angle bisector theorem. And then so in this box in the top right, I'm just going to write down this code, and you can see at the top of the page, what it will be. On the test, it's not going to look like this. I'm not going to have a spot for you to write down what theorem to use. But I'm putting this here as kind of a helpful guide. Hopefully it's getting you to think about that. So I know I'm going to use angle bisector. We'll come back to that in a minute. The next one, let's try and look in these 6 and find all the situations where we have mid-segment theorem being used. And can anyone identify some mid-segment? One and 6. And what is it we're looking for mid-segment? What is the, let me ask this, what is the clue, what is the giveaway that it's going to be a mid-segment problem and not anything else? Yeah, it's splitting the sides into equal halves, and what you're going to see are these congruency marks. So if you look at, I know 6 is kind of a fuzzier drawing up here, and kind of 1 is also. But anyways, you can still see these congruency marks. And if you see congruency marks, that is going to be a dead giveaway that it is mid-segment. I'm going to come back to mid-segment because that one's kind of the oddball of the group. But again, what I encourage you to do on your test, you're going to have multiple problems. It'll be somewhat arranged like this, we can say. And I encourage you to go through and just, before you try and solve all the problems, just kind of say, okay, this one's mid-segment, this one's angle bisector, this one is side splitter, this one's similar triangles. So now we have 2 diagrams left. You've got 18 more on the page where you can kind of apply this idea. But these last 2, which one is going to be side splitter? Three or 5? You got 5. Okay, that was a good guess. Or you knew it. So, good knowledge, I'll say. So that one's side splitter, and we're going to talk about what makes these different. Similar triangles right here for number 3. So remember, we talked about this just yesterday, so you haven't had a long time to process this. But the key thing for side splitter is that when the parallel lines cut through, and you could make these come together and come up to a point. So you're looking at a triangle, right, for number 5. But when you're looking at a side splitter problem, the distances given will be along the sides. So notice in number 5, you have 2, x, 8, and 12. They're only along the sides of that triangle. And I'll just draw that triangle in so you can see there is technically a triangle there. Oops, I didn't want that. All right, so if I kind of connect those together, there's your triangle, but the distances given are only on the sides. So use the name of it, side splitter, to kind of give you that mnemonic device, that sort of helpful reminder. So the thing that we're looking for in similar triangles, we talked about this yesterday. What is it that's going to tell us it's a similar triangles problem? It looks like a dilation, but to be fair, side splitter can do that too. Specifically, what we're looking at and what we're looking for is lengths given along the parallel lines. So 5 and h are parallel to each other. If the lengths given are along the parallel lines, then it's similar triangles. All right? So the fact that these, and I'm going to draw in the parallel markings on these, the fact that those distances are given tells me it's got to be similar triangles. All right, and I just want to quickly go over how we approach these problems in different ways. Luckily, angle bisector and side splitter, we kind of approach them the same way. And what do we need to set up for each of those problems? You've gotten a lot of practice with these the last few days. We will set up a proportion. There we go. I heard it. All right. So for angle bisector, we're setting up a proportion with a pattern of correspondence. So we can just set that one up for number 2. Tell me what this might look like. Well, we're looking at number 2. Okay. Can anyone set up that proportion for problem number 2? Yeah. 9 over 15 equals x over 10. Now this one I know is a little bit weird because the question mark, what we're solving for is the entire length. So when we're talking about x here, the x is simply that distance right there, and then we can figure it out. And some of these problems will be repeats, so if you went through all the work before, you might see some of the same problems. All right. So, side splitter, we kind of approach it the same way, remember? So we're going to set up a proportion. So for number 5, tell me how you could set up a proportion for that one. Twelve over x equals 8 over 2. That works for me. All right, remember, oops, not over x. Over 2. Remember, it's a pattern of correspondence. 12 over x equals 8 over 2. And you can kind of point to it and see the pattern that's happening. Okay, now let's look at the difference between the last two. We have mid-segment and similar triangles. I'm going to start with similar triangles because in the end, we're still going to set up a proportion. All right? But what we need to do is, when it is similar triangles, this is why it's important to identify that, we need to think of these as two nested triangles that are dilations of each other. So I'm going to have a small triangle right here and a big triangle, and I want to draw in these distances. I know the small triangle is 8 and 5, so the big one is going to be h, and what's on the other side? Not 32. What did you say? What did I hear? 40. Okay, so notice we need to draw these triangles separately. You can get by without it if you can do this sort of processing in your head, but I'll say a lot of people struggle with that, so I wouldn't recommend it. If I draw these triangles separately, I can see the 8 and the 5, that's still the same triangle. I just drew it, kind of extracted it from the diagram. And then the larger triangle that's left behind is still going to have that one side is going to be length h, and the other one is going to be length 40 when you combine everything together. So does that make sense? So we can go ahead and finish setting up our proportion here, and it's going to be what? Five over h equals 8 over 40. There it is. Comparing your corresponding parts. 5 and h correspond, 8 and 40 correspond, and we have the correct pattern of correspondence going on. Okay, the last one. So with these three that we've done so far, we're setting up proportions every time. And that's what's generally going to be the case. But mid-segment is a little different. Notice with our mid-segment problem, both of them, but we'll look at number 1, they only give us 2 distances. We can't set up a proportion with 2 distances. We need to have at least 4. 1 unknown and then 3 that we can work with. Okay. So with this, they only give us 2. So the key thing to remember with mid-segment, this goes back to what we did last week. I told you at the time it was the easiest theorem that we have, but it's also kind of a different one. And the main thing to remember is that 2 times your mid-segment equals the parallel side. Okay, so if we look at this one specifically in context, what we're saying is that the mid-segment right here, x plus 2, is half as long as 3x minus 5. So if we want to figure out what x equals, we need to double our mid-segment so that it is equal length with TR, that parallel side. So specifically for this problem, I just plug the mid-segment in right here. So 2 times x plus 2 will equal 3x minus 5. It's a not random, but it is a different sort of process you're going to do for this one. But do you remember doing that before? Okay, so hopefully it's coming back to you. I know it's been a few days since you've seen it again. That's really what we're doing for this worksheet. And your test is going to look very similar to this, so not set up exactly the same formatting. So any questions on this so far? If you are sitting there with a lot of questions right now, that's at least giving you some guidance to say you need to go back and review what all these theorems are telling us. Okay, and anyways, you have some time in class to work on this today, but it's also, we're not going to necessarily spend a lot of time going over this. So I'm putting it on you guys to now make sure that you're going through and practicing, and if you come across a bunch of problems and you're really confused on them, it's going to be up to you to get help from me or from someone who does know what they're doing. So if you were confused today, you at least have some guidance to say, I need to be doing a lot of studying.